This one is not going to be that bad. Find all the zeros of the function. Our first step, always, is to try and factor. But this is a fifth degree polynomial, and I can't like split it up in any cool way and factor like that. So really, I can't. If it's higher than a fifth degree, or sorry, if it's higher than like a third degree or a fourth degree, or if it has too many terms, we won't be able to factor. But that's always the first step. Try and factor. The next step, then, is to just take your guesses and use synthetic division. This is like we did in the other assignment. So here, you could write down P's and Q's. So my P's would be, I guess, this stuff, right? Plus or minus 1, plus or minus 2, plus or minus 4. And then Q, that's nice, plus or minus 1. So really, I'm just going to try, those. So my first guess would be, I always start with negative 1, actually. So I'm guessing for x plus 1. So I start with negative 1 there. Remember, you do the opposite of that. And then we have the coefficients. I have to check, remember, check for zero placeholders when you're doing synthetic division. This would be 5, 4, 3, 2, 1, nothing. Okay, so we don't need any placeholders. Then I have a coefficient of 1, of negative 3, of positive 5, negative 1, negative 6, and 4. Whoo, that's a doozy. So then I try this. Okay, so I'm testing out x plus 1, seeing if that's a factor. 1, negative 4, 4, 9, negative 9, negative 10, 10, positive 4. Hey, look at that. First try. So that's 0. So look at that. We had, I'll say this. That's my constant term. That's my x term. X squared, x to the third, x to the fourth term. So really, what I do have is x plus 1, that's this, because that's what I was testing out, times this polynomial. X to the fourth minus 4x to the third, right? Plus 9x squared minus 10x plus 4. Here's the thing. And we were setting it equal to 0, right? Because we're trying to find the zeros. So that should have been, I should have mentioned that. And then I try and factor again, but again it's too large, so I'll just do synthetic division all over again. Now here's the thing. If I have this factor, say I had this factor and it worked out, it could work out again. Remember, that would just be a repeated, like a multiplicity of 2. So I will start all over again with these. If x plus 1 did not work out, then I wouldn't have to try it again. Because if it doesn't work out the first time, it's not going to work out the second time. If it works out the first time, then it still might work out the second time. I can let's think about let's relate that to numbers. So this is just a side step. If I had 16 and I divided it by 2, that's kind of like what I'm doing here. I'm dividing, remember? That would be 8. But 8, so 2 goes into 16. But 2 goes into 8 as well. In fact, it goes into a third time. So like, even though it worked here, it still works here, and it still works here. So that's what I'm trying to say. Even though you divided this out, it still might be a factor of the rest of it. However, if you had 9 and you divided it by 2, well, that, of course, is not going to work. So then if you divide it by 3 and then divide by 2, of course it's still not going to work. That's what I'm trying to say. If you understand that, then great. If not, let's do, oh well. Alright, so again, I'm going to check x plus 1. I'm going to check it again. So that means I start with that negative 1, and now I'm using new coefficients. I'm using the coefficients of that. And I'm just going to keep reducing down until I get something that I can manage. So that would be 1, negative 4, 9, negative 10, and 4. I don't need any placeholders. That doesn't work. So it doesn't work a second time. Now I'll test out, and I'm just going to keep going. I'll test out x minus 1, which would mean I put in a plus 1 on the side. So I get, again, I'm still using these coefficients. So I would have, what was it? 1, negative 4, 9, negative 10. 1, negative 4, 9, negative 10, 4? Yes. All right. 9876. Look at that. That's so nice. So x minus 1 works. So my new polynomial is x minus 1, but also the x plus 1 from over there. X plus 1, that's on the very outside. And then my new polynomial constant, x squared, x to the third. This isn't so bad as long as you're patient. Some people aren't patient though. And then, can I factor this? No, it won't work out. So I do it again. I start over again. Remember, I don't need to check a negative 1 anymore. I am going to check the positive 1 though. So again, I'll write down x minus 1, just so I can make sure that I'm not missing any. And this would be a positive 1, 1, negative 3, 6, negative 4.
Hey, where do you get those from?
It's the coefficients there. 1, 1. I'm multiplying, right?
Yeah.
Negative 2, negative 2, positive 4. Look at that. Look at that. Look at that. And so, again, constant x squared. So I get x plus 1, x minus 1, and then another x minus 1, right? Because I had stuff there, and then the x minus 1. So one of the x minus 1s came from here, because it worked, and then the other one came from there. Sweet. Look at, we're just factoring away here. And then we get x squared minus 2x plus 4 equals 0. So, now what? Maybe I can try and factor this. If I try and factor, what would that be? 4, negative 2. I don't think that factors. Can't factor. But it says find all zeros. These zeros could be imaginary. What? So right now, I can say x equals negative 1. That's from this piece, by setting it equal to 0. And then also x equals positive 1 from here and here, so that's multiplicity 2. And then with this, x squared minus 2x plus 4, I'm setting it equal to 0, but I need to use the quadratic formula. Oh no, that's disgusting. Actually, it's not that bad. Remember, the quadratic formula is, this is a, b, and c. So you do, let's just write it down. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So then what happens? What happens here? Well, I'm just going to use that. So x equals negative b, well, it's already negative 2, so I make it positive 2, plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a is 1, and then c is 4, right? Yeah, it's 4. Keep up, come on. So then what do I have to do? I have to divide it by 2a, which in this case 2 times a is just 2. Alright, let's simplify a little bit. Uh-oh. X equals 2 plus or minus the square root of 4 minus 16. That's crazy. Divided by 2. So x equals 2 plus or minus the square root of 16, 50, 40, 30, 12. Negative 12. What? 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 Remember, square root of a negative. You can't really do that, but we have a term for it. and it's called an imaginary number. What? Because it's not real. There's no real number that works. But we would say x equals 2 plus, and then the negative comes out as an I. So I'd say I square root of 12 and divided by 2. So that's the first part, and then x equals 2 minus I square root 12, all divided by 2. And you could reduce that part. In fact, I will reduce it. What's the square root of 12? That's the same thing as 4 times 3, right? Which is 2 and 2. Anytime you have a pair, you take it out. So I have actually, looks like 2 root 3. So this is actually x equals 2 plus 2I root 3, all divided by 2. And x equals, this is going on forever, 2I root 3. I just want to be thorough. All divided by 2. And you could reduce, you could split up the fraction and reduce, but for right now, I'm going to leave it like that. Wait. Those are how many answers? I have 1, 2, 3, 4, 5. Was this a 5th degree polynomial? Oh my goodness, it was. Alright, good, we're done.